Forget every sci-fi movie you've seen about black holes. The real story of falling into one is far stranger, more terrifying, and utterly mind-bending. Imagine a place where time and space twist into impossible shapes, where gravity crushes you into a string of atoms, and where the laws of physics as we know them simply cease to exist. That's not just fiction, it's the predicted reality of a one-way trip into a black hole. But what happens during this ultimate cosmic freefall? What would you see, feel, and ultimately become? The answers will challenge everything you think you know about the universe and your very existence. The journey into a black hole isn't just a trip, it's a profound transformation into the ultimate cosmic unknown. It's a one-way ticket where there's no turning back, no emergency brake, and absolutely no escape. Everything we understand about this terrifying descent comes not from first-hand accounts, thankfully, but from the brilliant equations of Albert Einstein's general theory of relativity. This theory, which describes how gravity works, paints a picture that is both horrifying and utterly fascinating, pulling back the curtain on one of the universe's most extreme environments. Picture this. You're floating, drifting closer to one of these cosmic monsters. Maybe you got too curious, or maybe you were just incredibly unlucky. At first you might not notice much. The black hole, particularly a supermassive one, might seem like just another distant dark object. Its gravitational pull, while immense, wouldn't feel immediately different from the pull of a large planet if you were far enough away. You might feel a slight increase in your perceived weight, a subtle tug pulling you forward, but nothing overtly alarming. It's like being caught in a slow, invisible current in a vast ocean. But as you get closer, things start to change. The gentle tug becomes a relentless pull, and the subtle increases in gravity begin to work on your body in a truly bizarre way. This is where a phenomenon called tidal forces comes into play, and it's the beginning of the end for anything unfortunate enough to get this close. Think about the tides on Earth. The moon's gravity pulls on the side of Earth closest to it more strongly than the side farthest away, stretching the ocean and creating bulges. Now imagine that same principle but amplified beyond comprehension and applied to body. As you fall, the part of you closer to the black hole, let's say your feet if you're falling feet first, experiences a much stronger gravitational pull than your head, which is slightly farther away. This difference in gravity isn't subtle anymore, it's actively trying to pull you apart. At the same time, because gravity pulls everything towards the center of the black hole, it's also squeezing you from the sides. You're being stretched vertically, like a piece of spaghetti, while simultaneously being squashed horizontally. This process has a wonderfully descriptive, albeit gruesome name: spaghettification. Your body, your very bones and muscles would start to elongate and thin out, becoming a long, thin strand of matter, like toothpaste being squeezed from a tube. This agonizing stretch and squeeze intensifies with every foot you fall closer, making your approach to the next critical boundary an increasingly uncomfortable and ultimately fatal experience. Then you reach it, the event horizon. This isn't a physical barrier like a wall or a planet's surface. It's a theoretical boundary, an invisible line in the cosmic sand that marks the ultimate point of no return. It's the place where the black hole's gravitational pull becomes so unbelievably strong that nothing, not even the fastest thing in the universe, light itself, can escape its grasp. From your perspective, the person falling in, crossing this boundary, might feel unremarkable at first. There's no sudden jolt, no warning bell, no flashing neon sign. The forces of spaghettification are still at work, of course, relentlessly tearing at you. But the actual act of crossing the event horizon itself, it wouldn't necessarily feel like anything special. You'd just keep falling, oblivious to the fact that you've just stepped into an inescapable prison. However, for someone watching you from a safe distance outside the black hole, your journey would look entirely different and utterly bizarre. As you approach the event horizon, they would see you start to slow down, not because you're actually slowing down. From your perspective, you're speeding up, but because the light you're emitting is struggling more and more to climb out of the black hole's gravitational well. This struggle makes the light lose energy, a phenomenon called gravitational redshift. Your image would appear to stretch, dim, and slowly turn a ghostly red. The closer you got to the event horizon, the slower you would appear to move, the redder you would get, and the dimmer you would become, until at the very edge you would appear to freeze in time, like a photograph paused forever. Then, as your light completely failed to escape, you would simply fade away, vanishing from their sight, a cosmic ghost swallowed by the void. They would never see you truly cross that line, only disappear before it. Once you're inside the event horizon, the universe as you know it completely breaks down. The familiar laws of physics, the ones we use to predict everything from how a ball falls to how planets orbit stars, start to unravel and twist into incomprehensible forms. Inside, space and time don't just curve, they swap roles. Normally, you can move freely through space, left, right, up, down, but you can only move forward in time. Inside the event horizon, it's the opposite. You can't move freely through space anymore. Every path leads inevitably toward the center, and time, it becomes a direction in space, much like down. Your ultimate, inescapable destiny now lies with the singularity, the infinitely dense point, or perhaps region, at the very heart of the black hole. It's an unimaginable point where all the mass of the black hole is crushed into an infinitesimally small volume. Think of trying to crush an entire star down to the size of an atom. It's beyond our common understanding. As you plunge deeper, the gravitational forces continue to intensify to levels that are truly mind-boggling, far beyond anything conceivable in our everyday experience. As you continue your headlong plunge towards the singularity, the tidal forces, which were already turning you into spaghetti, reach their absolute ultimate extreme. The difference in gravity between one part of your body and another is no longer just stretching you, it's ripping you apart at a fundamental level. Your cells, your molecules, your very atoms would be torn asunder. Imagine something so powerful it could unravel the strong nuclear force holding atomic nuclei together, or the electromagnetic force binding electrons to atoms. Your body, already stretched and compressed beyond recognition, would be completely annihilated. Every single component, every proton, every neutron, every electron that made up would be ripped apart, stripped down, and crushed into that infinitely dense point at the center, the singularity. There would be no trace left, no remnant, no ash, just an addition to the black hole's already incomprehensible mass. It's the ultimate erasure, a complete unmaking. This brings us to one of the biggest, most mind-bending puzzles in all of modern physics. What happens to the that made you, you? Not just your physical body, but the precise arrangement of atoms that formed your DNA, your memories, your consciousness, everything that encoded your existence. The laws of quantum mechanics say that information can never be truly destroyed, only transformed. Yet, if everything is crushed into an undifferentiated singularity, where does that information go? Some theories, like the holographic principle, propose that this information isn't lost, but is somehow encoded onto the two-dimensional surface of the event horizon, like a cosmic hard drive. Others suggest it truly is lost forever, which would challenge some of the most fundamental principles of quantum mechanics, creating what's known as the black hole information paradox. It's a debate that keeps physicists up at night, because if information be destroyed, it means our understanding of the universe has a massive gaping hole in it. So, while your physical body meets a violent end, the question of your informational existence remains a profound mystery, stretching the limits of our knowledge. The journey into a black hole is a terrifying, impossible thought experiment that pushes the boundaries of reality and physics. From the initial tug of gravity to the final crushing embrace of the singularity, it's a testament to the extreme and awe-inspiring nature of our universe. It makes us ponder not just our own fragility, but the deep, unresolved mysteries that still lie hidden in the darkest corners of space. If you found yourself gripped by the thought of falling into the cosmic abyss, you won't want to miss our next video exploring the biggest black holes ever discovered.